So let's take this problem from JEE Advanced 2020 paper 1, which is from the topic application of integral, and the question is, let there are two functions. So they have taken two functions in this question, f and g, whose domain and codomain is the set of real numbers, and the function fx is defined by e to the power x minus 1 minus e to the power minus of mod x minus 1, and the function gx is 1 by 2 times e to the power x minus 1 plus e to the power 1 minus x, and the area of the region which is there in the first quadrant, which is bounded by the curve y equal to fx and y equal to gx, and the line x equal to 0. What would be the area? We have to find it out. So to start the question, let me look at the function f of x and g of x. Fx is, if I write the function f of x, now here there is mod of x minus 1, because of which the function will change its definition at x equal to 1. So before x equal to 1, that means when x is less than 1, mod of x minus 1 will be minus of x minus 1. Before that there is a negative sign, so the second term will be e to the power x minus 1, which is same as the first term of f of x, because of which this e to the power x minus 1 minus e to the power x minus 1 will get cancelled out, and the function f of x becomes equal to 0 for x less than 1. Now when x is greater than 1, mod of x minus 1 can simply be written as x minus 1. So the function will be e to the power x minus 1 minus e to the power minus of x minus 1 for x greater than 1. So this is how we can redefine the function f of x. Now coming on to this function g of x, which I will write it as e to the power x minus 1 half of e to the power x minus 1 plus e to the power 1 minus x, which I can write it as e to the power minus of x minus 1, because everywhere you can see x minus 1. So this is the function gx. Now let us see how is the behavior of these two functions to plot the graph of the function. So for that, first we will find out the first derivative of f of x. So when x is greater than 1, what will be the f dash x? It will be e to the power x minus 1 plus e to the power minus of x minus 1, because of this minus sign. So both are the sum of the exponential functions, so their value will always be positive for all the values of x which is greater than 1. Coming on to the function g of x, so I will find out g dash x. So what is g dash x? Here your g dash x will be e to the power x minus 1 minus e to the power minus of x minus 1. This is our g dash x. So when x is equal to 1, you can see g dash x is equal to 0. G dash x equal to 0 when x is equal to 1, and when x is less than 1, this value is first term will be less than the second term. So g dash x will be negative when x is less than 1, and when x is greater than 1, this first term will be greater than the second term. You can check it. So your g dash x will be positive when x is greater than 1. That means x equal to 1 becomes the point of minima for the function g of x. Now based on all this information, now we can plot the graph of fx and gx. So if you take f of x at x equal to 1, before that all the values your function is equal to 0, and when x is greater than 1, we can see that this function is always increasing. So graph will be monotonically increasing like this. Now when you take the function g of x, what will happen to g of x? This is at x equal to 1, we will have the point of minima. That means the function will move like this. Before x equal to 1, it is decreasing, and after that it will be increasing like this. So the required region will be this whole region, this region plus this region. Now we need to find out the point of intersection of these two curves. That means we need the x coordinate of the point of intersection, for which I need to solve the equation f of x is equal to g of x. So I will solve the equation fx is equal to gx. So fx is e to the power x minus 1 minus e to the power minus of x minus 1, and g of x is equal to 1 by 2 times e to the power. So 1 by 2, if I multiply inside the bracket, it will be e to the power x minus 1 plus 1 by 2 times e to the power minus of x minus 1. Now this e to the power minus of x minus 1 comes on the left hand side, becomes 1 minus 1 by 2, which is 1 by 2 times e to the power x minus 1, and this minus of e to the power x minus 1 comes on the right hand side. So this becomes 3 by 2 times e to the power minus of x minus 1, and then if I multiply e to the power x minus 1 in both the sides, I will get e to the power 2 times x minus 1 is equal to, this 2 is cancelled, so I will get only 3. So if I take log in both the sides, what will happen if I take the log? It will be 2 into x minus 1 equal to log 3. So x will be equal to, minus 1 comes on the right, becomes plus 3, and 1 by 2 log 3 will be log of root 3. So the x coordinate of this point will be 1 plus log of root 3, 1 plus log of root 3. This point is having the x coordinate equal to 1. So the required region can be divided into two parts. First part is between 0 to 1, where it is only the area below this region, which is for the curve gx, and from 1 to 1 plus log of root 3, it will be area under the curve gx minus area under the curve f of x, which is this particular region. So I will find out the required area by breaking this region into two parts. The first part will be going from 0 to 1. So I will write integral from 0 to 1, which is exclusively only g of x, which I can write it as 1 by 2 times e to the power x minus 1 plus e to the power, this is minus of x minus 1. This is for the first part, and for the second part, the limits will be from 1 to 1 plus log of root 3. So I will write 1 plus log of root 3, and this is the region gx minus this region, which is for f of x. So your gx can be written as 1 by 2 times e to the power x minus 1 plus 1 by 2 times e to the power minus of x minus 1, and minus of this region, that means this is minus of e to the power, this is x minus 1, and then this minus and this minus becomes plus. So this will be plus e to the power x, e to the power minus of x minus 1, e to the power minus of x minus 1. This whole thing we have to integrate with respect to x. Coming on to the first integral, here the integral of e to the power x minus 1 is simply e to the power x minus 1, and e to the power minus of x minus 1 will be minus of e to the power minus of x minus 1, and the limit I will have to substitute from 0 to 1. And for the second integral, I will write it as, first is I can take this plus this. So this is e to the power x minus 1 minus e to the power, this is 1 by 2 minus 1 is minus 1 by 2. So I will write it as integral from 1 to 1 plus log of root 3, and this is, first I will simplify this expression, which is 1 minus 1 by 2, which is minus 1 by 2 times e to the power x minus 1, and this is 1 by 2 plus 1, which is plus 3 by 2 times e to the power minus of x minus 1. Integrating this also with respect to x. Now we will evaluate both the integrals. So if I put x is equal to 1, this will be e to the power 0 minus e to the power 0. So 1 minus 1 will be equal to 0. So the first part will be, this will be 1 minus 1, which is 0, minus, when I put the lower limit, this is 0 minus 1 will be e to the power minus 1 minus, if I put here also x equal to 0, it will be e to the power minus of minus 1, which is e to the power 1. Now coming on to the second integral, if I integrate this value, the first thing is this is minus 1 by 2 times e to the power, this is x minus 1, and here because of this minus sign this becomes minus 3 by 2 times e to the power minus of x minus 1, and here also the limit will be from 1 to 1 plus log of root 3. Now let's solve them. This is 1 by 2 times minus minus will be plus, so it will be e minus e to the power minus of 1. So this is equal to 1 by 2 times, this is e minus 1 upon e, so it is e minus e to the power minus 1. This would be the first integral, and the second one will be plus, this is when I am putting x is equal to 1 plus log of root 3, this is 1 plus log of root 3 minus 1, so 1 and minus 1 will be cancelled, this will be minus of log of root 3, which can be written as log of 1 upon root 3, and e to the power log of 1 upon root 3, e to the power log of 1 upon root 3 will simply be equal to 1 upon root 3. So this will be, if I put here, it will be minus 1 by 2 times, I said log of e to the power log of root 3 will be equal to root 3, and when I put here x is equal to 1 plus root 3, this will be e to the power minus log of root 3, e to the power minus log of root 3, which can be written as log of 1 upon root 3. So e to the power log of 1 upon root 3 will be 1 upon root 3. So this is minus 3 by 2 times 1 upon root 3. Okay, this would be over here. Then I put x is equal to 1. If I put x is equal to 1, this is 1 minus 1 is 0. So this is simply minus 1 by 2. And here if I put x is equal to 1, this will be again e to the power 0 is 1. So this is minus 3 by 2. So I will write here minus 3 by 2. Now simply put the values. So this is e 1 by 2 times e minus 1 upon e. So you can say e minus e to the power minus 1. And this is minus 3 root 3 by 2. This minus 3 upon 2 root 3 means this is root 3. So root 3 by 2 and minus root 3 by 2 becomes equal to minus of root 3. And this is minus 3 by 2 minus 1 by 2. Actually when I am taking minus sign common, this is 1 by 2 plus 3 by 2. So this is minus of 2. So this becomes minus of minus 2 becomes plus 2. So the final answer will be half of e minus e to the power minus 1 plus 2 minus root 3, which is matching with the first option. So the first option will be the right answer to this question.